Recently, a company called ITEHIL reached out to me and asked if I would be interested in testing out and making a video for one of their reverse osmosis portable water filtration systems. I said sure, and a few days later, they sent me one of these babies. And what this thing is a 100% portable, off-grid, fully reverse osmosis water filter with its own internal rechargeable battery and hoses and everything you need. You can deploy this thing pretty much anywhere in the world, no matter how yucky the water is, and have yourself a source of completely clean and purified drinking water. And we've all seen the various types of portable water filters before, the Sawyer Squeeze and the Life Straws and all that. But this is actually the first electric reverse osmosis filter that I've seen that works completely off the grid, I guess. So in this video, I'm going to be doing an unboxing and setup and trial run and full-on test of this filtration system, and with what I'll say is the highest level of scientific accuracy that I'm capable of. We're gonna put together some various nasty looking water, run each one of them through this thing, check how clean it is, see how long it took to filter that water, just sort of check out all the various aspects and features about using this thing. And as much as I'd love to take this thing out into the bush and find some dirty creek and do a kind of a real life example of using this thing, it just so happens to be the middle of winter in Michigan. It's about 14 degrees outside, and there's just pretty much no way that I'm gonna be doing that. So in the name of getting this video actually made sometime before, I don't know, April or May, we're just gonna be doing it right here in my kitchen with some various nasty jars of water that I've put together. So let's get into this box and see what we're dealing with. Right away, I'm noticing the very convenient carrying handle on the top, which makes it quite nice to pick up and move around. I haven't read the instructions or anything on this yet, so I don't exactly know what I'm supposed to be doing. I see a couple of outlets here on the back for some hoses and also on the front. There's also a chamber here at the top, which appears to be where I will put some filters, which I assume are in this box here. And on this box, there's kind of a, maybe, hopefully, idiot-proof diagram of exactly how to connect everything. I'll definitely be referencing that again. And we got our hoses and our filters. And I'm not quite sure what that is. And a storage bag with some extra hoses and stuff in there and some other kind of filter element. Now right here on the front of the unit, there's this little control panel, and as part of that, there's a USB-C charging port. So I think before I really do anything else, I'm gonna plug this thing in and make sure that it's fully charged. Because again, this entire thing is battery powered and meant to be used in a somewhat off-grid sort of situation. And the whole setup does come with this charging cable, but it doesn't actually seem to include a little charger brick thingy. But luckily I have plenty of these lying around from other things, so I'm sure it'll work just fine. But I am noticing right away that the cord that comes with it has the USB-C end on both sides, and pretty much all of my little charging bricks use a normal USB sized plug. So I guess I'll end up using one of my plugs from something else and just kind of hope that works. I don't see why it wouldn't. And there's a red light blinking next to the word charge, so I'm guessing that it's working fine. So I'll give this a little while, make sure it's all charged up. Hopefully there's a way for me to tell that it's fully charged. Maybe this light will turn green or something. And then we'll finish setting this thing up and give it a try. Now in the meantime, let's talk about how I'm actually going to sort of test out the effectiveness of this system beyond just simply observing the machine working. And while I don't have any elaborate testing equipment or materials for doing bacterial testing or viral testing or anything like that. What I do have is one of these simple water testing meters, and it will test for a couple of things. And the useful one in this case is the particulate testing aspect of this device. Basically, I take this probe, put it in some water, and it will tell me how many parts per million of any kind of particulate it detects in that water. It's not telling me what kind of particulates are in it, be it bacterial or anything else, but it does provide a sort of good indication of how much stuff is floating around in my water, both before and after I run it through this filter system. And as sort of a means to test the test, I've got here a jug of distilled water right from the store. And I'm gonna fill this mason jar up with a bunch of it and see what the particulate reading is with the little device from this fully distilled water. I'm hoping, and in a perfect world, that number should be 0, but I guess we're gonna find out. So I've just gotta put the little meter in here to about this deep, give it a couple of stirs, wait till it starts doing something. Hopefully it'll show me something on the screen. And the screen just continues to say 0 parts per million. So that's exactly what I want to see. So I'll go ahead and set up a couple of my other test liquids and see what they say. All right, next up, I've got some tap water straight out of the faucet. Now, at this house, I have municipal city water, which means it's chlorinated and probably highly treated. And I would expect that the parts per million would be very low. So let's give it a test with the old meter, and right away I can see that it's doing something. This thing was in there for about a second before it showed me a reading of 111 parts per million. Now, from just some quick reading on Google, it would seem that anything below 500 parts per million in water that is otherwise considered okay, or from an okay source, such as, I guess, municipal tap water, isn't really any cause for alarm. But if this number was 500 or more, no matter what kind of particulate it was, it's recommended that the water has further testing. Now, I'm a little surprised that this highly treated and chlorinated and filtered water straight from the municipal facility still has a ppm of that high. I've never really checked it before, so I don't honestly know if that is out of the ordinary. I guess I can probably assume that it's not. Nevertheless, we have our baseline for the tap water, so I'll be interested to see what that number is after the filtration. And while it's too cold for me to get a sample of rainwater outside, I do have some snow out there that hasn't melted yet, and I'll go ahead and scrape some of it up off of my filthy driveway, load it up into this mason jar, and then I'll just let it sit on the counter for a while until it totally melts. And of course, I've got it labeled so I don't forget which jar is which. And I have no idea how dirty snow itself is, but having sat on this driveway for several days, I'm sure it's going to be pretty gross and full of particulates, which is exactly what we're testing for. Now, in trying to think of some other ideas for sample liquids that are clearly just absolutely swimming with particulates, I thought about some good old-fashioned tea bags. Obviously, when you make a cup of tea, that hot water is just completely riddled with the particulates making up the tea itself. So I'll just throw a couple of these tea bags into the jar, fill it up with some water that I've brought to a boil, and I'll mention that I decided to use distilled water for this because I already know that the ppm of the distilled is 0, so using it should give me an accurate portrayal of how much ppm came from the tea bags themselves. And I'm gonna wanna let this go ahead and cool down basically entirely to room temperature before I start putting, the probe or hoses or anything into it. That's okay, we'll come back to it in a little bit and get that reading. And just because I wanted to get more of a real world example of some truly nasty water that somebody could encounter out there in the wild, I figured I would whip up a nice jar of straight up dirt water. Dug down a little bit into one of my garden beds, got some topsoil and mixed with God knows whatever else has been in there for the last several months. Throw that into a jar, fill that up with some more distilled water. And there's no way around how putrid and disgusting this sample is. Now, when I try to take the ppm reading for this absolute dirt water, my device starts kind of glitching out, and I couldn't really make any sense of why it's doing that. And when I read the instructions, it says that this thing will only measure up to 999 ppm. So all I can guess is that it won't tell me really anything if the number's higher than that. So I guess I can't really get a reading on the dirt water, but I think we can probably all agree there's a lot of nasty stuff floating around in there. All right, it looks like this thing is all charged up. I got the green light, so let me pull that charging cord out of there and we can get this thing set up. First, I need to get the filter elements installed into the machine. This one is called the hybrid filter, which is really more like the activated carbon. And I think I just gotta get that in there. There we go. And then I'll do the same with the reverse osmosis one. I can close the lid on that and we can look at our hoses. Now there's two different outlet hoses, and one of them is for the filtered water and the other one is for the wastewater. When you do reverse osmosis, you have so much water that goes in and not 100% of that water comes out as filtered water. So you end up having some wastewater. And the instructions say that you should still collect this water and use it for things like cleaning or boiling, that sort of thing. And I guess maybe I would if the water looked pretty clean to begin with, but considering some of the nasty water I'm going to be filtering today, I'm sure I won't use it for anything. But anyway, I'll end up setting these up so these go into two different jars. And then for my water input, I need to attach this end to the filter. It looks like it needs to screw in. Don't love that there's not an easier way to screw that in, because doing so has gotten my hose all twisted, but I guess that's okay. I'll just untwist it from the end. And then this end of the hose has this little sort of pre-filter thing on the end of it, and this is what will go into my dirty water that needs to be filtered. So let's see if I can get this all arranged on the counter so everything's in the video. And before I do any of the actual filtering on my experiment water, the instructions do recommend running some kind of water through this thing for about 10 minutes the first time you use it. So I've just got a cup filled up with some tap water here, and I'll get a couple of these containers set up so I can collect the water from both of the output hoses. I don't love how stiff and unwieldy these hoses are, because it's going to make it difficult to actually get them into these containers without the weight of them and the bend to them wanting to knock everything all over. So I'm going to have to figure this out a little bit, see how I can position all this stuff so everything doesn't just topple over. Okay, I guess the cardboard box and the binder clips helped me out here, keep everything together here. So I'll go ahead and turn this on. All right, this thing started cranking out the water, the wastewater on this side, the completely filtered water on the white side here. I actually already had to empty the wastewater side once because of how much more quickly it fills than the filtered side. This thing seems to produce more than twice the wastewater as it does the filtered water, which I guess is about what's to be expected with a reverse osmosis system. So I'll just let this go a few more minutes until everything seems like it's good and primed up with these brand new filters, and then we'll start the actual experiment. And I guess we'll go ahead and start with the tap water, just because it's the cleanest of the ones we'll be testing, I guess. I'll put the end of the intake hose in there with the little filter end, and from what I'm seeing, it empties out a quart container of water pretty quickly. So each one of these little experiments probably won't take too long. Then we'll get our wastewater container back in place, and you know, I think I'm actually going to get something a little bigger than this because of how much more it puts out. I think I'll use an empty gallon jug right here. And we've got the empty jar for the filtered tap water, which will come out of the machine. And And let me see if I can get this binder clip back in here to help me out. Now we'll just turn this thing back on and let it go. So it's only taken about 25 seconds to almost empty this jar, which means I probably should have started with bigger containers for this experiment, because I'm not going to end up with very much of the filtered water from each of these quart jars. But I think that's okay. I think it's still enough for us to be able to do the test as needed. I think it just means that I'm going to have to pour my filtered water into a much smaller vessel so I can use that little water meter in it. Actually have enough volume in here, vertically anyway, to get a reading on that thing. So if you remember, the tap water right out of the faucet had a reading of 111 ppm. Let's see how it does after going through the filter. And it's reading 14. So I'd definitely call that a big improvement. Still not zero, but a whole lot better than 111. Now here we've got the snow water, and it's melted, and I'm going to end up having to put more of that snow in here just to get this jar filled up a little higher to actually get enough out of the machine to make this kind of a worthwhile test. But as long as I've got it right here, and it's, well, mostly melted what was in there so far, let me get a quick reading on it. And the reading is 148. So I guess that's the number to beat in our disgusting driveway snow. So it's a little while later. I've gotten more snow melted in here, along with all sorts of twigs and sticks and crap that just went into the jar from that driveway. So I'll throw my filter end in there. Got the after jar all set up and ready to go. And let's go. All right, let's get this moved over to the little shot glass. And we're looking at 20 parts per million. So definitely another huge improvement. Okay, so next up I think we should do the tea. And let me remind myself what the ppm on this tea was. And it's pretty high. It's 346. Which is definitely very full of particulate. So dropping the old intake hose. And it's pretty clear by looking at the wastewater line on this one that it's definitely quite tea colored. So that's pretty interesting to see that in action. As for the filtered water, crystal clear and beautiful. And we're at just about 21, 22 ppm on the meter. So yeah, I'm thinking that's kind of our sweet spot for filtering the nasty stuff. Last but not least, we've got our jar full of dirt water. And since this has been sitting a little while, obviously a lot of that dirt has settled to the bottom, but you can still see how murky and gross that water is. Just for the heck of it, I tried it again with the water meter, and it still can't really even register the number because I think it's just way too high. So let me just run this through the filter and see what we can do. And I've clearly mixed up the labels on these jars because this is certainly not after and this is not before. So I'll just keep close eye on that, and I think it'll be obvious which is which once this finishes filtering. Well, this water smells completely clean and tastes completely clean, but let's try the meter and see what it says. And I don't really know how to make any sense of this, but it's actually cleaner than the tea or the driveway snow at 10 ppm. Not sure how to make any sense out of that, except maybe the particulate in this dirt was just bigger, so it was more likely to be filtered out. Either way, I'll take 10 ppm, and that's just fine with me. Considering that it was so high that the meter couldn't even really tell me a number before I started, I'd say that 10 ppm is pretty impressive. And after doing all these different tests, it's kind of interesting to see the water that I've ended up with. And, admittedly, most of that color in there is from the tea experiment. The water was relatively clear for the other ones. With the dirt, it was kind of murky looking, but still nothing as colorful as the tea. I'm a little curious of what the ppm on this slurry will be. Not that it really matters, but just for the sake of curiosity, maybe I'll test that. And we're looking at about 226. So not great, but honestly, that's just maybe about 100 ppm worse than the original tea reading was. So I don't know. I don't think I'll be washing any dishes with this or whatever it was that the instructions suggested I could do with it. So all in all, this machine seems to have done exactly what it was supposed to do. I'm pretty impressed with the speed at which it filtered, considering how small the unit is and the fact that it's entirely battery powered. And before we wrap this up, let me read off just a few of the specs and details from the product website for this thing. According to the ITEHIL website, it says that the filters should provide somewhere between 600 and 800 gallons of filtered water before they need replacement. And that's pretty good considering that the filters are kind of small. As far as the output, well, I obviously wasn't measuring the rate as it went when I was doing my tests, but the website says that it will put out 17 fluid ounces or 500 milliliters of the filtered drinking water per minute. So with some simple math, I can say that that means that it would take about 7.5 minutes to filter 1 gallon of water. So I guess that's about it. But before we wrap it up, I'll mention that a couple years ago, I made a video in which I built and demonstrated a homemade water distiller. I took some of the nastiest water you ever saw, ran it through the distiller, ended up with a jar of perfectly crystal clear, absolutely drinkable water, which I did drink, but I didn't do it on camera. And ever since then, I've been kind of getting the business and being called out for not having done that. So in an effort to make sure that no one has anything to say about that, of course, I will drink some of the water that I just filtered. And this is from the last batch that I did, which was that absolutely dirty, dirt-filled water from the garden box outside. Anyway, if you want to check out the ITEHIL portable, battery-powered, reverse osmosis water filtration system for yourself, I'll put a link in the video description below. And also be sure to check out the coupon code that I put down there in the video description to get a pretty decent discount on one of these things if you want to buy one. And be sure to like and subscribe and stay up to date with all our latest stuff, including future product reviews and water purification videos. And consider supporting us on Patreon at patreon.com/Great Lakes Country. Thanks for watching, and until next time, I'm John, and this is Great Lakes Country.